Okay, from this section, we will shift our attention to from finding the sum of series to deciding whether a given series is convergent or divergent. And the reason is it's very difficult to find the sum of the series in general. So that's why we need to shift the attention. So we have two tests to begin with. The first one is divergence test. It is the easiest one. And the second one is the integral test. Let's begin with the divergence test. Now, again, this so-called divergence test, you only use it to test divergence. You cannot use it to test convergence. So I put a warning here because I've seen so many students are abusing this rule in an incorrect way. Now let's first begin with reading this divergence test statement. So it says, if the series converges, then the limit of the AK, the kth term, the limit when k approaches infinity is equal to 0, which means if the series converges, ultimately the nth term will be approaching 0. Now, this statement is not that useful. Its contrapositive is more useful. So equivalently, and that's why I put that into black box right here. So if the limit of the kth term is approaching 0, then the series diverges. So make sure that, again, like I said, many students use it incorrectly. So when they say, hey, usually the incorrect application is this. They claim that when the limit is 0, then they say it converges. This is not true. This is totally not true. Okay, this is totally not true. So you don't think if this is true, then this is true. This is incorrect. In fact, if this is approaching 0, we know nothing about convergence, divergence. It will be inconclusive. All right, let's apply this theorem 8. So, in order for us to see if this divergence or if it's divergence, check the limit of this term. You can see that it is approaching 1, right? The limit is 1. Now, because it's not 0, you can conclude that this guy diverges. This series diverges. And let's look at the this guy here. The top is 1 plus 3 to the k. The bottom is 2 to the k. And you do see that the top is bigger and the bottom, which is the denominator, is smaller. So which means it's greater than 1. The limit is greater than 1. So which is not 0 as long as the limit is not 0, and it will diverge. So therefore, we can conclude that the second one diverges. I suppose you can do the B without too much trouble, D without too much trouble. And let's look at the next one, E. And the limit of 1 over k plus 1 is approaching 0. So be careful now. When it is approaching 0, we know nothing, right? So here we cannot say it converges, and we cannot say it diverges. We just say the divergence test doesn't help at all. So inconclusive in this case. So be very careful. In this case, how do you continue? Use some other way. Now take a look at E. The E says k over natural log of k, and you do know that k is approaching to infinity faster than the natural log of k, right? So we do know this is approaching infinity, which is not 0. So we know it is divergent for E.